All right. Well, welcome to What's Up Over Edmonton for December 2024. My name's Jeff Robertson, and I'm a member of the Royal Astronomical Society of Canada, Edmonton Centre. And as I announced back in October, uh, this is the last What's Up Over Edmonton. Um, I've been doing this for over 4.5 years. It was originally conceived as a live event to be done at the Queen Elizabeth Planetarium when it reopened. However, the pandemic put a halt to that, so we started doing it online. And by the time things started getting back to normal, we agreed that it's just best to keep doing it on Zoom. So I call this What's Up Over Edmonton because the skies over Edmonton at 53 degrees. Oh, I should explain the picture first off. Okay, it's winter, it's cold outside, and we get to see uh, a couple features. The first one, which I just clicked away from, unfortunately, is an ice pillar, or pardon me, a light pillar. And this picture here is a sundog, and these are formed by ice particles suspended in the air, refracting the sunlight, almost making a bit of a rainbow. And they are things we can see in the wintertime. I call this What's Up Over Edmonton because our skies here at 53 degrees north latitude are a lot different than what is presented in many popular astronomy publications like Sky and Telescope and Astronomy Magazine, and is what is also talked about on the Weather Channel and on CBC. And the example I've been using for years now is this. This is the sky over Toronto on July the 5th, 11 o'clock, and the constellation circled is Scorpio, the scorpion. It is completely visible in Toronto and in southern Ontario, well above the horizon. However, in Edmonton, this is as high as it ever gets. We're just that much further north that we only see the top of Scorpio on the same day at the same time. And it's also not only what we can see, but how we see it. And this is a picture I took of a conjunction in February 2023 of the moon in the top upper left, Jupiter in the center, and Venus in the lower right. And you can see they are on a bit of an angle, a bit of a slant. That same night, my wife's cousin was in Buenos Aires, Mexico, which is at 23 degrees north latitude, quite a bit further south, quite a bit warmer. And the moon is at the top, Jupiter's in the middle, Venus is at the bottom, and they're almost in a straight line down to the horizon because the ecliptic runs that much higher at those latitudes. Most of the information comes out of the Observer's Handbook, which is put out by the Royal Astronomical Society of Canada every year. It is 352 pages of just about anything the observer would want to know. And the 2025 edition arrived in my mailbox, thankfully, before the strike. And I have already thumbed through it quite a few times. So, what do we got in December? We got long, cold nights, short, cold days, and an unending string of bad Christmas movies from Hallmark on the TV. And I'm sorry to say my wife is really likes those movies. And I even sat down with her and watched Hot Frosty last week. So, what do we got? We got two new moons this month. We've got Jupiter at opposition on the 7th. Mars begins its retrograde motion. The Gemini meteor shower peaks on the morning of the 14th, and the Ursid meteor shower peaks on the 22nd. And the winter solstice is on December the 21st. So I'll start what I call the planetarium section. And I went a little long this month because I was kind of wrapping things up. So here we go. Let's look at what we can see in the skies over Edmonton for the month of December 2024. And as you can see, I have replaced our grass background with the Arctic hellscape we're all living in, thanks to all that snow we had at the end of November. So, as always, we'll begin with sunrise and sunset times. So, on December the 1st, the sun rose at 8:28 and it set at 4:17. for 7 hours and 49 minutes of daylight. Astronomical twilight ended, that is, night officially began at 6:26. On December 31st, New Year's Eve, the sun will rise at 8:50. It will set at 4:24 for 7 hours and 34 minutes of daylight. Night begins at 6:35 p.m., and those are all Mountain Standard Times. Mercury is not visible in the evening sky. It's simply too close to the sun at this time, and it also reaches inferior conjunction, that is, it passes between the sun and the earth on the 6th and moves into the morning sky, although it is going to be quite low, and we'll talk about that in a little bit. Looking at the evening planets, Venus has become quite prominent in the southwest sky. At the beginning of the month, it's setting at 7:09. By the end of the month, it's setting at 8:40 p.m. And if we look at Venus through a telescope, you will see it is a gibbous phase. Moving up the ecliptic, we come to Saturn, the ringed planet. It is now well past opposition. So for those planets that have passed opposition, I will just give the set time. So on the beginning of the month, Saturn sets at 12:05 a.m. On the 31st of December, it is setting at 10:16 p.m. So we are rapidly losing Saturn in the evening sky. Moving up the ecliptic, we come to Neptune, which shines at magnitude 7.8, so you will need a telescope to make out its blue disk, and in a larger telescope you might even be able to make out its big moon Triton. Neptune sets at 1:26 a.m. at the beginning of the month and 11:33 p.m. at the end of the month. Moving along the ecliptic, we come to Uranus. In a telescope, well, at least in my telescope, it has kind of a turquoise hue to it, a bluey green. It looks quite nice. As Uranus has passed opposition, I will say that it sets at 7:09 a.m. on the 1st of December and 5:05 a.m. on the 31st. So it's, for all intents and purposes, it's up all night for viewing with a telescope. Moving down from Uranus, we come to Jupiter, the king of the planets. Jupiter reaches opposition on the 7th of December, which means it rises as the sun is setting. So, at the beginning of the month, Jupiter rises at 4:34 p.m. By the end of the month, it's rising at 2:23 p.m. Jupiter's going to be visible in the sky all through the winter, and it makes an excellent target, but when it's at opposition, it is at its closest point to Earth. As always, even in a small telescope, you can make out its 4 Galilean moons, the 4 big moons. There are 3 of them in this view here. There we go, pull out a bit, and we can see all 4 of them. And on this particular view on December the 19th, we have Io over on the top right, and then Europa, Ganymede, and Callisto on the lower left. As I pointed out before, Jupiter's day is only 10 hours long, so in the course of a single night, you can watch one complete rotation of Jupiter. The last of our planets in the evening sky is Mars. Mars will reach opposition on January the 16th, but it rises at the beginning of the month at 8:12 p.m. By the end of the month, it's rising at 5:41 p.m. And if you look at Mars through a telescope, even a 4 or a 6-inch telescope will show dark and light features on the surface of Mars. Mars is really the only planet that we can actually see stuff on its surface. And I'll come back to Mars in just a few minutes. I did mention at the beginning of the evening planet section that we could not see Mercury. However, it does make an appearance in the morning sky. It is fairly low. And here I've set the time for an hour before sunrise, and starting around December the 12th, Mercury pops into view from Edmonton. It reaches its greatest western elongation, that is, its greatest distance from the sun, on Christmas Day on the 25th, and then begins to set again. And by the end of the year, on December the 31st, it is just above the horizon as viewed from Edmonton. And if you can find a spot with a clear southeast horizon an hour before sunrise, you can try and spot Mercury with either binoculars or your naked eye, or both. The moon is new on December the 1st. On the 4th, it is near Venus. On the 7th, it is approaching Saturn. On the 8th, it is between Saturn and Neptune. On the 12th, it is approaching the Pleiades and the planet Uranus. And on the 14th, it is near Jupiter. And on the 17th, it is near Mars. I should point out that on the morning of the 18th, the moon will pass very close to Mars, less than half a degree away. So if you're up at around 10 minutes to 2 in the morning of the 18th, you can see the moon and Mars very close to one another, less than half a degree apart. They will fit into the field of view of most telescopes. It'll be quite the sight. Might even make a good photograph. Before we leave the moon, on December the 7th, the moon would be near Saturn. Also, for the last time this year, it's time for the Lunar X. As I've mentioned every time I've talked about the Lunar X, it is a transitory feature, and it is caused by the sun illuminating the tops of craters around the crater of Lunar. And it happens just before first quarter moon. On December the 7th, the Lunar X appears in Edmonton skies around 8 o'clock. I have two different times. One says around 7:36, one says around 8:40. So let's just split the difference and say, look for the Lunar X around 8 o'clock. The Lunar X lasts for around 4 hours, which means when the moon sets at 11:30, it will still be visible. Find a good location with a clear horizon to the southwest, and use a telescope to see the Lunar X and also the Lunar V, which is a result of the same thing that causes the X, the sun shining on the tops of crater rims. Let's return to Mars for just a few minutes. Mars, like all the planets, moves through the zodiac along the ecliptic, and they move from west to east. And if we watch Mars starting in August and watch its movements week by week, we can see in August it's in Taurus, moving through Gemini, and entering Cancer. Now, on December the 7th, the Observer's Handbook notes that Mars is stationary. And what that means is Mars is about to do this loop-de-loop in the sky. It's going to stop going from west to east. It's going to start going backwards. So what's going on? That is called retrograde motion. What causes it is, as the Earth is catching up to Mars in its slower orbit, its appearance against the background stars seems to change, and as Earth catches up with Mars and reaches opposition, Mars falls behind the Earth as it appears against the background stars, and as Earth pulls out further and further ahead, eventually the appearance of Mars against the background stars stops and then resumes its eastern motion, because the planets, as they look from Earth, are always going east from night to night. Now, the ancients had a problem with this because, well, Mars revolves around the Earth. It shouldn't do that. So they came up with the idea that it was revolving on a celestial disk that was invisible to us. As you can see here, it would go around and around as it orbited the Earth. An analogy I thought of when I was at Disneyland for the first time on the teacup ride was, this is very much like the teacup ride, where all the teacups are going round and round, but the teacups are also spinning on their own little circle. So if you've been to Disneyland and if you've been on the teacup ride, that's an analogy to retrograde motion. I should mention that all the outer planets do this loop-de-loop in the sky. It's not just Mars. It's just because Mars is so close to us, its motion is the most apparent. We have a couple meteor showers in December. The first is the Geminids, which peak on the morning of the 14th. Unfortunately, we have the moon 1 day away from full, which is going to obscure all but the brightest of meteors. The Geminids is a pretty good shower. It's been reported you can see 80 to 100 meteors per hour. And this shower is not caused by a comet, it's actually caused by an asteroid, 3200 Phaethon, which has a 524-day orbit around the Sun. It's known as an Apollo asteroid. It's an asteroid that gets closer to the Sun than the Earth. And there is the radiant there in the constellation Gemini. The other meteor shower is the Ursids, which peaks on the morning of the 22nd. It arises from the Earth passing through the debris left by comet 8P Tuttle, which is a 13.6-year period comet. It's not a very active shower, only 5 to 10 meteors per hour. The moon is at first quarter, which means it's going to be rising around the time of the peak. And there is the radiant there near the constellation Ursa Minor, the Little Dipper. As with all meteor showers, get away from the city lights, take a blanket, take something hot to drink, take a friend, and take a comfortable chair. With the Geminids, only the very bright meteors will be seen, as the moonlight will be washing out all the fainter ones. The winter solstice occurs on December 21st, the shortest hours of daylight all year. And on that day, the sun will rise at 8:48, set at 4:16, for 7 hours and 27 minutes of daylight. It's the official beginning of winter, although winter arrived in Edmonton in November. This is the point in the Earth's orbit where the sun has moved its farthest point south. It sits over the Tropic of Capricorn in the southern hemisphere. It is summer in the southern hemisphere, winter in the northern hemisphere. In Antarctica, the sun never sets above the Arctic Circle. The sun never rises above the horizon. Let's close this session off with having a look at some of the things we can see in the night sky. And for this simulation, I've set it for 10 p.m. on December the 25th. Picked that date not because it's Christmas, but because I didn't want the moon in the sky. So if we look straight north, we see Ursa Major, which includes the Big Dipper, rising up into the sky. By springtime, it will be directly overhead. And you'll recall only about 6 weeks ago at this time of day, the Big Dipper was riding along the horizon. And if you follow these two stars, Dubhe and Merak, the pointer stars at the end of the bowl of the Dipper, they point directly at Polaris, the North Star, which sits almost directly over the North Celestial Pole. Over in the northwest, we see Cygnus and Lyra, two of the three constellations whose brightest stars make the summer triangle, are low on the horizon. So if we look straight up, we see Perseus is near the zenith, almost straight above, and next to it is Cassiopeia. If we look straight south, we have three of the major constellations of the winter sky. We have Taurus, the bull, Orion, the hunter, and Gemini, the twins. And below Orion, we see the very, very bright star Sirius, which is part of the head of Canis Major, the great dog. Sirius is the brightest star we can see from Earth. And joining Taurus, the bull, is Jupiter within the horns of the great bull. In the summer, we have the very famous asterism, the summer triangle. But there is a winter triangle, not as well known, and it consists of stars Betelgeuse, Sirius, and Procyon. And there is the winter triangle there. Not as well known as the summer triangle, but it is 3 bright stars in the winter sky. And not only is there a winter triangle, there is a winter circle, or a winter hexagon, depending on how you see it. And that is made up starting at the very top of Capella in the constellation Auriga, Aldebaran in the constellation Taurus, Rigel in the constellation Orion, Sirius in the constellation Canis Major, Procyon in the constellation Canis Minor, the little dog, and Pollux in the constellation Gemini. And that is the winter hexagon, or the winter circle. Looking in that same area of the sky, we can see a number of deep sky objects, and we'll start with the most obvious one, M45, the Pleiades. Known as the Seven Sisters, it resides in the constellation Taurus, and it is an open cluster of newly formed stars, probably maybe 1 million, maybe 2 million years old. Long exposure photography shows the cloud of nebulosity around them in which these stars originally formed. Can be seen with the naked eye. A little difficult in the city, but it can be spotted. And certainly they're very apparent if you get out to a dark site. Another open star cluster, similar to the Pleiades, but a lot closer to us, so we don't get the impression that it actually is an open star cluster, is the Hyades, which to the naked eye is a V-shaped pattern of stars that make up the head of Taurus the bull. In the constellation Gemini is NGC 2392, commonly known as the Clown or Eskimo Nebula, and it is a planetary nebula, the result of gas thrown out by a sun-like star in the final stages of its life. And in the same general area of the sky is NGC 2264, commonly known as the Christmas Tree Nebula. A nice way to get into the spirit of the season. In this view, it looks kind of like an upside-down Christmas tree with some decorations on it. And a mandatory stop anytime you're scouting around this area of the sky is the Great Orion Nebula, M42. It is the nearest star-forming region to our solar system, and it is a favorite target of mine. I always stop and have a look at it when Orion is in the sky. Of course, it doesn't look colorful like this. It looks more like this. Those are just a few of the deep sky objects you can see. I've turned on the labels to show all sorts of other ones. So I'll just close with a couple other comments. A few things to look forward to in the coming year. Of course, as I've been mentioning for a while, Mars is at opposition on the 16th. It will be at its closest point to the Earth. It will be very bright in our sky, shining with kind of a orangey reddish color. And, as I mentioned earlier, Mars and the Moon have a very close approach. In December, there is a similar approach to the Moon on the 13th of January, a few days before that opposition. Here's a view of it here. Beginning on the evening of March 13th, 2025, and going into March 14th, there is a total lunar eclipse visible from Edmonton. The Earth enters into the umbra of the Earth's shadow at 11:09. It is fully within the shadow at 12:06, and the moon begins to move out of the umbral shadow at 1:31. So that's something to look forward to in the spring. And finally, back in June, we were talking about the blaze star T Corona Borealis, a star that is going to go nova any day now. The smart money said it would be going nova before September. Well, hasn't happened. It could happen tomorrow, or it could happen sometime next year. At this time of year, if the star did go nova, if you did want to see it, you'd have to get up fairly early in the morning because it is out of the evening sky. It is set already, but it does rise around midnight. So if you hear that T Corona Borealis has gone nova, get up after midnight, go out and have a look. It'll be low on the northeast horizon. As I've said before, this is the last session of What's Up Over Edmonton. I've been doing it for over 4 years, and I just feel it's the time to step away from it. No one has stepped forward to take up the mantle. So this is the last planetarium session in What's Up Over Edmonton that I will do. There's always stuff to see in the sky, whether it be comets or novas or meteor showers, the movements of the moon and planets, or old friends that we keep going back to. I will conclude this session with this.
Watch the skies everywhere. Keep looking. Keep watching the skies.
Yeah, I thought some people might like that. Any questions, comments?
No, I'm new to this, so I'm just going to say I appreciated every session that we've had. I'm hoping that sometime in the future somebody else will take over. Won't be me for a while. I'm still trying to learn this stuff. I don't even know how to get my telescope to work properly. So, maybe in 10 years.
Well, we do have how to use telescope sessions every now and again. So.
Oh yeah, no. I'm just saying I'm too newbie to do what you just did. So.
Oh, I see. Okay. All right. Okay. All right. Well, if there's nothing else.
Jeff.
Yes.
This is Jane, and
Hi, Jane.
Hi. When you're talking about the retrograde that Mars is going to do,
Yep.
if you stood and watched it long enough, would you actually see that loop happening?
No, you'd have to watch it over, day to day.
Okay.
In the simulation, I was just jumping 7 days at a time.
Okay.
So, yeah. So if you went out and took a picture, I guess you could do that too, or just go out and note where it is, and then come back a few days later, and you'll see it.
All right.
It's moving backwards.
Okay. Well, thank you.
Okay. All right. Okay, we'll go on to the moon.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows a path.
Okay, the moon was new on December the 1st. First quarter is on December the 8th. That's this coming Sunday. The moon is full on the 15th. And in December, the full moon is known as the cold moon. It's also known as the long night moon, the oak moon, the snow moon, the winter maker moon, and the chief moon, among other names that it carries. Third quarter is on December the 22nd. And the moon is new again on the 30th. So I normally pick a feature for Off the Moon from one of the lists from the RAC Explore the Moon certificate programs for either telescopes or binoculars. Today is found in both certificate programs. And it is the crater Eratosthenes. Eratosthenes is a prominent crater at the southern tip of the Apennine Mountains, and that's one of my images there with the big arrow pointing at it. It's 59 kilometers across, and it is 3.5 kilometers deep. It has a circular rim and terraced inner walls, a central mountain peak, and an undulating floor. Now, it is overlaid with rays from the nearby crater Copernicus, that guy right there, which lies to the southwest. The crater was believed to have been formed about 3.2 billion years ago. And at low sun angles, as this picture of mine shows here, the crater is prominent due to the shadow cast by its rim. It becomes visible about 8 days after new moon. And this is an image I took on day 8 with the crater near the terminator, with the sun illuminating just the rim. And here's another one a day later. It's a bit grainy, sorry about that. But I am the world's worst astrophotographer. And you can see Copernicus off to the lower left. Now, at full moon, when the sun is directly overhead, the crater blends in with the surroundings so much, and it becomes difficult to see. And that's because the rays thrown out by which is ejecta from the crater Copernicus, which is a much younger crater, lie across the area where Eratosthenes resides and kind of act as camouflage. Just disappears. Eratosthenes becomes easier to see 21 days after new moon, until third quarter when the sun sets on the crater. And here is an image taken by someone who knows what they're doing of the crater after full moon. And this is taken from lunar orbit, showing the floor, the terrace walls, and the central peak. The crater was named after Eratosthenes of Cyrene, who lived in the 3rd century BC. He was a mathematician, geographer, poet, astronomer, music theorist. He was a very learned fellow, and he became the chief librarian at the Library of Alexandria, which was kind of the great center of learning in the ancient world. He's best known for being the first person known to calculate the circumference of the Earth, which he did by using an extensive survey results he could access in his role at the library. And his calculations were remarkably accurate, with a margin of error being less than 1%. And he was also the first person to calculate Earth's axial tilt. Now, when What's Up started, Alistair Ling and Berta Bertrand were doing a complimentary series called Introduction to Stargazing, and they based the series on the RASC's Explore the Universe certificate program. Now, when they ended that series, I added a feature, Constellation, to the monthly What's Up. And through the years, I've done all the winter ones at least once, and Orion I've done 3 times. I like Orion. Lots to see there. And even though it is the featured constellation in the 2024 Observer's Handbook, I'm not going to do it a 4th time, so relax. This is one I've only done once. And it is Auriga, the charioteer. And this is the star field it resides in. This is the astronomical drawing. And this is a drawing of what the constellation is supposed to represent. Auriga, the charioteer, is a prominent winter constellation, has a rough pentagram shape. The constellation got this name because its major stars form a shape similar to that of a pointed helmet of a charioteer. Auriga was first cataloged by the Greek astronomer Ptolemy in the 2nd century CE. And in Greek mythology, Auriga is often identified as the mythical Greek hero Erythonius of Athens, who was raised by the goddess Athena, and he was generally credited to be the inventor of the 4-horse chariot, which he used in battle. And his chariot was created in the image of the sun's chariot, the reason Zeus placed him in the heavens. Capella is the brightest star in the constellation. It is the 3rd brightest star in the northern sky. It is circumpolar in Edmonton, that is, it never sets below the horizon. And it is featured in just about every picture I've ever seen of noctilucent clouds because at that time of year, it's lying low in the northern sky. And find Capella, in case you doubt it, locate the top two stars of the Big Dipper and trace a line to Capella, just like that. Now, although it appears to be a single star to the naked eye, Capella is actually a quadruple star system with two pairs of binaries, and it is approximately 43 light years away. The primary pair, Capella A and Capella B, are two bright yellow giant stars, both of which are around 2.5 times as massive as the Sun. And the secondary pair, Capella H and Capella L, are two small, faint, cool red dwarfs. Auriga contains 3 Messier objects. They're all open star clusters, Messier 36, 37, and 38. 36, 37, and 38. And this is a wide field photo showing all 3 of the Messier objects. Messier 36 is also known as the pinwheel cluster, and it lies at a distance of about 4,100 light years, contains at least 60 stars, and bears a resemblance to the Pleiades in the constellation Taurus. However, M36 is about 10 times further away than the Pleiades. M37 is the brightest, richest, and largest of the 3 open clusters, and it has an apparent magnitude of 6.2 and lies at a distance of 4,500 light years from Earth. Lastly, Messier 38, known as the starfish cluster, because of its shape, lies around 4,200 light years from Earth and is an apparent magnitude of 7.4. It is invisible to the naked eye. So we'll go to space history. This is where we look at a past event that not only occurred in this month, but whose anniversary year is divisible by 5. So in 2024, we look at events in years ending in a 4 or a 9. Now, I was kind of stuck for an event for this month that met the criteria I set up way back in May of 2020 when I started this. However, I did eventually find something that occurred within the parameters that started as an event that occurred in December, but the whole event ended in January of 2025. So I made the rules, so I'm going with that. But first, some background. Cassini was a joint project between NASA and the European Space Agency to send a probe to orbit Saturn, where it would study the planet and its moons. The Cassini spacecraft was the size of a small bus. It was 6.8 meters tall and 4 meters across. Its high gain antenna at the top, and it weighed 2,523 kilograms empty. Fully fueled, it weighed 5,574 kilograms. The spacecraft was named after Giovanni Cassini, a 17th century Italian astronomer who, among other things, discovered several moons of Saturn, as well as a division in that planet's rings that bears his names. Now, attached to one side of the spacecraft, protected in an aeroshell, was Huygens, an atmospheric entry probe, which was designed to gather data on Saturn's largest moon, Titan. It would gather data and transmit it back to the orbiter until its batteries were depleted. The probe was named after Christian Huygens, a 17th century Dutch astronomer who determined the nature of Saturn's rings and discovered its largest moon, Titan. Now, prior to the Cassini mission, Saturn had been visited 3 times by spacecraft, Pioneer 11 and Voyagers 1 and 2. All of these were flyby missions, and all had made examinations of Titan. They found the moon was enveloped in thick clouds of nitrogen and methane, which obscured the surface. The atmosphere of the moon was determined to be thicker than Earth's. Huygens' mission would be to enter Titan's atmosphere, where it would gather information and transmit it back to the orbiter, which in turn would transmit it back to Earth. The Huygens probe was 1.3 meters in diameter and weighed 316 kilograms. And this is a photo I took of a full-scale mock-up of Huygens in the Science Museum in London. And it was protected during its entry into the atmosphere by a 2.7 meter wide heat shield aeroshell. And here you can see Huygens in the aeroshell prior to the top of it coming on top and sealing in the craft before it's attached to the Cassini. Huygens carried 6 instruments to collect and transmit science data as it descended through Titan's atmosphere. They measured atmospheric density, composition, wind speeds, temperature, and pressure. The probe also took in samples of the atmosphere during its descent for analysis. Cameras imaged Titan's surface while it descended under parachute, as well as on the surface when it landed. It also had a microphone to record any sounds. On October 15th, 1997, Cassini-Huygens began a 7-year voyage to Saturn atop a Titan 4B booster. Now, even though the Titan 4 was one of the most powerful rockets in the U.S. inventory at the time, the probe would need 2 gravity assists, flybys from Venus, 1 from Earth, and 1 from Jupiter to fling the big probe on to Saturn. On June 25th, 2004, Cassini-Huygens fired its motor and slowed into orbit around Saturn. It would orbit Saturn until September 2017, where it was directed into Saturn's atmosphere and burnt up. 20 years ago, this month, that's how I get to squeeze this in. Cassini-Huygens was on a trajectory that would intercept Titan on January 14th, 2005. So on December 25th, the Huygens probe was released via a spring mechanism on Cassini. And this is a very pixelated image of Huygens taken from Cassini as it moved away. Because Huygens ran on batteries and would not encounter Titan for 3 weeks, the probe was asleep, except for an onboard timer that would wake it up just before it encountered Titan. There was a tiny heater powered by radioactive decay of plutonium to keep the instruments inside warm. On January 3rd, 2005, Cassini fired its engine to divert it away from Huygens, otherwise it would have crashed into the moon too, while Huygens continued on the intercept course. 3 weeks later, on the 14th of January 2005, Huygens woke up and prepared to enter Titan's atmosphere. Entry interphase began at an altitude of 1,270 kilometers and a speed of 21,600 kilometers an hour. At maximum braking, the probe experienced a force of 12.3 Gs, and the heat shield was exposed to temperatures hotter than the surface of the sun. When the onboard accelerometer detected a deceleration of less than 10 meters per second, a pyro charge ejected the pilot chute, which stabilized the probe. Following that, a second pyro fired, allowing the main parachute to deploy. And 32 seconds after that, the heat shield fell away, and the probe's transmitters were switched on. And floating under its parachute, Huygens would take 2.5 hours to reach the surface of Titan. This is a video of the descent of Huygens to the surface of Titan, first as an animation, and then with images taken by Huygens as it made its way to the surface. As Huygens broke through the clouds, a landscape of mountains, hills, and plains were revealed. There were channels that would turn out to be cut by liquid methane. All through the descent, Huygens took measurements of the moon's atmosphere and imaged its surface. All this data was transmitted in real time, first to Cassini and then to Earth. Cameras on Huygens took pictures of the descent from different angles. Huygens saw methane frost atop peaks. And methane in the air is broken down by the weak sunlight, forming organic compounds which give the atmosphere its orange color. Winds at various levels blew Huygens in different directions during the descent. The landing site looked like a dry lake bed with rounded rocks all about, and the shadow of Huygens' parachute is seen in the top of the image, deflating after landing. Photos from the landing site suggested there was evidence of liquid recently acting on the surface. While a hydrocarbon lake or sea did not currently exist at Huygens' landing site, further data from the Cassini mission confirmed the existence of permanent liquid methane lakes on Titan. The temperature at the landing site was minus 179.3 degrees Celsius, and the atmospheric pressure was 1.45 atmospheres. Huygens found the brightness of the surface of Titan at the time of landing to be about 1,000 times dimmer than full solar illumination on Earth. The last data received from Huygens occurred an hour and 13 minutes after it landed, when Cassini moved out of the line of sight and could no longer receive its radio signals. Huygens' batteries died shortly afterward. Today, Huygens rests on the surface of Titan and is the first and so far only craft to land on the moon of another planet. Since the beginning, I've always mentioned heavensabove.com. It's a great source of information. You can print custom star charts. You can check satellite sightings. If there's any comets in the area, you can print finder charts for that. It's just a great source. And no, they're not paying me to say that. Next meeting of RASC Edmonton is on Monday, December the 9th at 7:30 p.m. You can attend in person in the Ziegler Dome at the TELUS World of Science or attend on Zoom. The link is on our website. Now, for the past 4.5 years, it's been my honor to put together What's Up Over Edmonton for you. And I look back on the early ones that I didn't think, ew. But I've tried to improve them each time, and I hope those of you who've joined me live and those who've tuned in on YouTube got something out of it. And we're encouraged to go outside and look up. As Douglas Adams wrote in The Hitchhiker's Guide to the Galaxy, space is big. You just won't believe how vastly, hugely, mind-boggling big it is. And there's lots to see and lots more of us, and lots more for us to discover. There's the note. And I'll just close with this.
It's,
So,
it's appropriate.
any questions?
That's appropriate for us old people.
Yeah.
Well, Jeff, you have done a fantastic job. I'm really going to miss all of this and your sense of humor. Oh my goodness. You have me laughing many times.
Oh, well, thanks. Thanks. All right.
But all of this, your space history that you've been doing, like I know that we'll be able to access on YouTube, but I think because um, the classes might be more specific to a certain date, that I wonder if your space history will get kind of lost if people don't access them as time goes on. And I was wondering if there was a way that you could put together your space, separate out the space history clips that you've done because you've put so much time into them and just have them be separate
Oh, I've
from,
never thought of that. Huh.
yeah, because really you've really put a lot into it. And I've never really been a space nerd, but I'm really finding it so interesting. It's just fascinating.
Hmm.
So anyway, just a thought. If you get bored watching Hallmark Christmas movies and the Oilers and stuff, okay.
Yeah, no, I won't get bored watching the Oilers. It was a pretty
Maybe
good
the
game.
Hallmark Christmas.
Yeah, the Hallmark Christmas movie. Yeah, but yeah, it was a pretty good game last night.
Yes.
They bad they couldn't get a goal past Quick, but or not Quick.
Yes.
What's his name? But anyway, yeah. Oh, and congratulations again, Murray, for getting the Messier certificate.
Thanks,
Good
Jeff.
job. Good
Thank
job.
you. And thank you so much for these WhatsApp. I haven't seen very many of them live, but I have been checking some on YouTube, and it was a great job, Jeff. Thank you.
Thanks. Yeah, I was talking to, I know Murray. I was talking to Lori the other day, and I said, it's been 25 years. On December 31st, it'll be 25 years from the Y2K frenzy, and it doesn't seem that long ago to me, but geez, it's a quarter of a century.
That's right.
Yeah. I remember that shirt you had. Oh, you fixed it. Yeah. All right. Well, is there any thank you. Any other questions, comments, or anything? This is being recorded. I'll edit out some of the mistakes and be on YouTube in a day or two if you want to go back or tell your friends or whatever. So I say it's oh, thanks, Kat. Thanks, Steve. Thanks, Gina. Yeah. And can always go back and look back at them, I guess. And I'll consider what Jane said about putting all the history things as separating them out. It'd be easy to do because it's all on my computer. So yeah.
Yeah, even in the description, if you put which space mission or spacecraft you're mentioning, that's one way of.
I could edit the description on YouTube, couldn't I? Yeah, never thought of that.
Yeah, I thought about it too because I'm like, Jana, you're all the things you do with the history of space. I love it, especially the Apollo space program. But
well, I grew up with it, and I had a list of books picked out to recommend, but I left that part out because I thought it was getting a bit too long. So
yeah,
but,
it's good. I'm getting near the end of A Man on the Moon. It's I think I'm on page 526 or something like that. It's the best book ever.
Yeah, it's a pretty good book. I have it, of course, and there's another one that I really like. It's called Apollo. Hang on, see if I can
Mike
reach
Collins
it.
book. Yeah.
Oh, the Mike Collins book. Yeah, I got that one too. Yeah, Carrying the Fire. Yeah, it's called Apollo: The Race to the Moon. I'll just turn off my background here. That's not what I want to do. Just background. Done. Yeah, it's this one. It's called Apollo: The Race to the Moon. It was published in the 90s, I think, or the 80s.
Nice.
1989. Excellent book. Yeah.
Well, who's the author on it?
Charles Murphy and Catherine Cox.
Cool.
Yeah. I don't know if it's still in print, but maybe the library has it. I don't know. Yeah. Anyway, excellent book.
Yeah.
Oh, I see someone got the Observer's Handbook in time too. Excellent.
Yeah. I
Yeah,
just happened to stop by the mailbox tonight too. I got mine as well. It's just, this is
Ah.
excellent.
Oh, okay.
I got mine a couple of weeks ago.
Yeah, I did too. Before the strike, it showed up, so
Yeah, me too.
I was happy. I was happy I got it. So, and we'll have our calendars at the meeting for sale, but I've already ordered 3, so I'll pick those up on Monday. 2 for Christmas presents and 1 for me.
Is that observer's book specific to our area? Or is,
But the Observer's Guide?
yeah, like I've never looked at one.
Oh, well, that's for the whole country, really,
The whole
and the
country?
U.S. They sell a lot in the States. It's very general, but excuse me. Yeah, it just, some of the stuff they talk about, like transits, moon transits and Jupiter and stuff, the timing, a lot of them don't work for Edmonton because we're just so far west.
Mm-hmm.
But it's a very excellent book, and there's all sorts of information in there on eclipse timings and meteor showers, etc. It's just got, there's a lot of stuff in there.
Okay.
A lot of stuff, yeah. And you can order it from the RASC, but who knows when you'll get it if you order it now, because of course, they mail stuff. Yeah.
Well, I'll take a look at one time and see if I should start ordering them.
Oh, well, yeah.
Yeah.
Or, yeah, okay. All right. Well, if there's nothing else, thank you very much for tuning in on this last edition of What's Up, and clear skies, although we don't have clear skies right now, but hopefully we'll have some better skies going forward. And maybe we'll see our nova pop, and maybe there'll be another comet of the century come around. I think I mentioned last month, comets of the century come around about every 10 years. So, yeah, you never know. We've had 2 since I started doing this, 2 naked eye comets since I started this. So, odds are good.
Mhm.
Awesome. Well, thank you,
Okay,
Jeff.
yeah.
Appreciate it.
Okay.
Thank you.
Thanks, Jeff.
All right. Thanks
Good
very
night.
much. And thank you, and good night.